Keelan. That one's frozen over here. And
Good morning. How are you doing?
I'm good. How are you?
Doing well, thank you.
Good, good. All righty. So we will go ahead and get started. Let me get the right location. Go ahead and go right now. We need to open some of that curtain for you. In. Yes, it will fall. You just have to.
I just called it. I just called it. Don't say it.
Now we're focused. It'll be all right. We'll stick it back up. It's not a big deal. All righty. So I'll go ahead and get my screen going. That's not what I need. I mean, I'll need it in a minute. Why did it open at the very beginning of the book? Let's see.
Who's that? Is he good?
It's getting there.
What? I think it's not on some price. I think I would not have. I had to do
Okay, so I can see where we left off. 5. Okay, this is where we left off. Is that right? We got page 113, 12 through 18 evens. Is that our first? 105. Not gone too far. All right. That there. This one here. And then we'll be ready to roll. Okay, starting on page 105, we will start checking our homework. If we have questions, we will go to them. So on 105, it looks like we had numbers 8 and 10 and 11.
Just 8 and 10.
8 and 10? Okay. Because we did 11 right there. Okay, so we had numbers 8 and numbers 10. So if we look at number 8, the given was that segment AB was congruent to segment BC. Segment CD is also congruent to BC. And so how did you need to set up your equation on that one?
2x plus 1 plus 4x minus 11.
Okay, since we know that they're congruent, we had to set them equal to each other. And so let's see, we found,
2x plus 1 equals 4x minus 11.
okay, 2x plus 1 equals 4x minus 11. So what did x equal? 881. Back.
I got 10 over 6. That's probably wrong.
Just a second. Let me get to. There's the A. Okay, so this is 5. Okay, so we had 2x plus 1 equals 4x minus 11. Okay, and so as we were going through these, kind of looking at the different steps, so we set them equal to each other. And then the first step is to move 4x from the right to the left. So we have to subtract 4x. So 2x minus 4x is negative 2x. So on the left side, you have negative 2x plus 1 equals negative 11. Then you're going to have to move your negative 11 using this addition property of equality. I'm sorry, I should have said that a minute ago. The first step was using the subtraction property of equality to move 4x. Then we're having to use the subtraction property of equality to move 1 from the left to the right. So we are going to have to subtract 1 from the left, subtract that from the right. And if I have negative 11 and I take away 1, I owe mom $12 and I just borrowed 1 more, what is that number going to be? Negative 12. Okay, so if you subtract 1 from each side, you end up with negative 2x plus equals negative 12. So when I divide both sides by negative 2, then you should have ended up with x equals 10. No, x equals 6. Why did I even say 10? Where did 10 come from? X equals 6. And that was using the division property to be able to solve for that. Okay? Questions on number 8?
Yeah, I did it completely wrong. I just added the 2x to the 4x and
Okay.
added the 1 to the negative 11. So I got 6x plus negative 11.
Okay, yeah. So
Yeah.
remember, when we're trying to solve for x, we want to isolate x on one side and the constants on the other,
Okay.
and then solve for x.
Yeah, I see what I did.
Okay. All right. So number 10, we were given that ST is congruent to SR, QR is congruent to SR. Okay. So we can see that we've got QR and SR covered, and we can see that SR and ST are covered. So what is our property here?
Distributed?
Well, our first step, we are going to have to distribute, but we can see that because ST is congruent to SR and QR is congruent to SR, then we can conclude that ST is also congruent to SR. Okay? So the way we're going to set this one up is we are going to be following the same thing, except for, yeah, we're going to go ahead and set them up equal to each other. So our first step is distributive property, where we have to distribute that 5 to 3x minus 2. So you should have ended up with 15x minus 10 is equal to x plus 4. Then I need to move my x term by subtraction property. So I subtract x from each side. So I have 14x minus 10 equals 4. Then I'm going to have to move that negative 10 from the left to the right. So I add 10. So that's going to be the addition property of equality. Add 10 to each side, and I end up with 14x equals 14. Division property tells me I can divide both sides by 14, and I end up with x equal to 1. Any questions on that one? Okie dokie. So then we moved on down to the next page, and we have number 16. And so the first one, developing a proof, and it says that we've got a proof here, and it says our given is that UV is congruent to XY, and VW is congruent to WX, and WX is congruent to XY. And we can see the figure that they've drawn it out to kind of be able to look at those different figures, okay? So we can see that UV and XY are smaller segments based on the drawing than VW and YZ, okay? So it says that we need to prove that UW is congruent to XZ. Okay, so what they did is they gave us our statements, but they jumbled up the reasons. Okay, so they gave us the statements and jumbled up our reasons, so we have got to unscramble those. Okay, so let's go ahead and take a look. What do we know that the first statement, what is the reason for the first statement going to be? Given. We talked about how usually every single time we see a proof, write a proof, the first step will be given. Okay, so that's our given. And then when I look at the next one, I've gone from my given and I have that segment VW is congruent to segment YZ. Okay, so which property do I use for that one? Transitive. Good, the transitive property. Okay. All right, then step 3 says that UV equals XY and VW equals YZ. So, okay, remember we talked about how when I see those equal signs, that's kind of a key to me that I'm dealing with a definition. And so that's going to be our definition of congruent segments. Step 4, I am adding UV plus VW, and that is equal to XY plus YZ. Okay, that's going to be the segment addition postulate. Okay, because remember we talked about how when we add the segments, since we're adding segments, that's going to be, I'm sorry, you're right, I jumped a step. That is the addition property of equality. My bad. Number 4. Number 3 was the definition of congruent segments. Okay. Number 4 is the addition property of equality. Okay, and then 5, when I jumped ahead, we have UV plus VW equals UW, and XY plus YZ equals XZ. So this is the segment addition postulate, okay? Because we're showing where we add them together and they equal the bigger segment. Okay, and then step 6, UW equals XZ. When we look at step 5 and we move to step 6, what are we noticing is different here? What is missing from step 5 to step 6? Well, the congruent symbol, but look at step 5. We have that UV plus VW is equal to UW, and I have UW in step 6. Step 5, I have XY plus YZ is equal to XZ, and in step 6, I just have XZ. Actually, I could probably blow this up a little bit, make it a little bit easier to look at.
You're taking the solutions.
So notice, going from this step here to this step here. Okay, I've got this here and I've got this here. So what I've done is I have just substituted. Okay, I have been able to eliminate these parts right here and these parts right here and substituted UW for this right here is equal to XYZ, which is XZ. Okay, so the substitution property allowed me to substitute these two equal to each other. Okay, and then finally, step 7, we've got segment UW is congruent to segment XZ, and that is the definition of congruent segments. Okay, so this is something that it's going to take some time to get used to. All of these definitions, and we've like I said, we've kind of created this pool of definitions, and that's why I did remember to bring my folder. So during the break, I'm going to copy these and hand them out to you so you can just stick them in your folder. This is what I've done. I think I've done all of chapter 2 already. So 1 and 2 is done for you. I'll copy them. You can just stick them in your folder. Keely, I'm dropping this one in the mail to you when I'm done this afternoon. So this one will be headed your way. So anyway, so these are the kind of things like our definitions and our postulates and our theorems. So then that way, as you're doing your homework, instead of having to flip through 6 sections in your textbook, you'll have 1 chapter per piece of paper. Okay, so that's my goal, is to kind of, and so I set this one up for you. You can see it's a lot of writing, it's a lot of information. But at least it's compiled on one page, so it'll make it a little bit easier, okay? So anyway, we'll be looking at these a good bit and talking about, you know, when I say, hey, this is a blue folder or something. And then what we can do is kind of make a list of things that you need to add to your folder, okay? All righty, and then we had number 18. All right, so number 18, we needed to try our hand at writing our own proof for this one. And so we have the given that NK is congruent to segment NL, and that segment N, or that NK is equal to 13. So we have to prove, yes.
For the blue folder, can we just like type it out and put it into new paper into the folder?
You can do it however you want to, it's yours, okay? So you can figure out how you want to do that, okay? Now, some of the things it involves like drawing pictures and stuff like that, so I don't know, you know, if you're a whiz on the computer and you can do the, you know, symbols, that, I've done a few of those, and it's kind of, if you're a whiz on the computer, I'm sure that'll be fine. It took me forever. But anyway, but yeah, or you can type it up and then just draw the figure right next to what you've typed up. So however you want to do that is great. Alrighty, so number 18, we are looking at how we can write this. So let's say, okay, let's say worst case scenario, you don't have a clue how to write a proof. What do you know you're going to get points for? Well, trying. And so if you're trying, then you know that when you write this as statement 1, and what is the reason? The given. See, like you're not going to make a 0 on a proof because you're always going to know that your given is going to be reason 1, or statement 1 and reason 1. Okay, so we are given that information. All right, so to get from that information to our proof, let's think through what we would need to do there. Okay, so we've got the given. So what would our next step need to be that we need to show to be able to get from here to here? What do we need to show?
Like
Yeah, that NK and NL are congruent. Because if I can show that they're congruent to each other, then I can justify that they, I can go ahead and put this. So my first step, and actually let me, okay, so I'm going to put an S over here and R for my reason. Okay, so 1, we have NK congruent to NL, NK equals 13, and 1 over here was the given. So step 2, I need to show that NK is congruent to NL. Okay, so by showing that NK is congruent to NL, using the definition of congruent segments. Okay, so once I've defined that NK is congruent to NL, what can I prove after that? That NL equals 13, and what are we using to show that? Close. NL equals 13. Looking here, what do we know about NK from the given? That it's congruent to NL, we know that, but what do we know right here that NK, my little symbols are not that great. NK is equal to 13, right? And we're trying to prove that NL is equal to 13. So if I put NK is congruent to NL, yes, we're using the substitution property there because we have substituted, we've got NL, now we're substituting A and 13 because in our proof and in our first step in our given, we tell that that is equal, okay? So step 3 is that we're using the substitution property. That's not too bad. Just 3 steps, and the given was one of them. So all we had to do,
Oh, that's it. I have like 4 more.
well, once I've gotten here, this is what it says I need to prove.
Okay.
So once I get to what I need to prove, I'm done. Okay. So all I had to do was show that we already knew from the given that those were congruent. And so we just had to show that that using our given, we knew that this was the definition, and then that NL, all we had to do was substitute. And you know what, I probably what the confusion is I said definition of congruence, but it's supposed to be an equal, not a congruent sign, and that's what messed it up. I was used to writing my little wavy sign. Okay. All righty. Like I said, I will not be giving you proofs on a test that you totally have to freehand and go from start to finish with statements and reasons on your own. Okay. I'm either going to give you a mix, kind of like number 16 was, how you had your statements, but then you had to unjumble the reasons. We may see some of those. We may see some where I have missing steps or missing statements and missing reasons, and you just have to fill in or whatever, okay? I think it's the kind of thing where I would rather you be able to look at it and have a little bit of help on determining how I get from here to here and make that reasoning connection, versus being so frustrated with proofs that you absolutely hate them and you miss the whole purpose of them. Okay. Yes.
Like I just don't know which one goes.
Right. And so that's kind of the learning part of it, and we'll be kind of trying to review that as much as kind of starts to stick a little bit, because all this is such, and we've got a lot of it at one time. Okay, we've got a lot of stuff coming at us at one time. Okay, so that was number 18. So moving along, we get to page 107, and we had numbers 105, we had 105, 8, and 10. We already did that. 106, 16, and 18, and now 107, 32, and 34. So let's take a look at those. So it says in exercises 31 through 34, use the diagram to find the angle measures. So we kind of have to use, or actually if we look at number 32, it says the measure of angle 8 is 70 degrees. So what is the measure of angle 6? What type of, what is the relationship between angle 6 and angle 8? They are congruent because they are vertical angles. Vertical angles are congruent, and if they're congruent, then they have the same measure. So if measure of angle 8 is 70 degrees, then the measure of angle 6 is also 70 degrees. Look at 34. The measure of angle 7 is 108 degrees. What is the measure of angle 8? So what is these two? They make a linear pair, and I know that a linear pair is equal to what? 180 degrees. So if I know that these two together is 180 degrees, I subtract one, I can find the measure of the other. So 180 degrees minus 108 degrees equals 72 degrees. Very good. Any questions on those? Like I said, these are the things that I'm kind of thinking through. I'm working on, yes. Did I not go back far enough when we were checking homework? I'm sorry.
I remember in 99. Oh yeah, they did.
Yep. Sure enough.
What number was it?
Let's see how far back. Okay, so let's flip back for a minute. I didn't go back far enough. So our last homework the time before was page 101. So it's going to be after page 101. Is that right?
That's the one moving. Unless I just did it for fun of it.
I'm getting my dates all messed up. So last week we did start at 91 because that was 9/9, because we met on the 9th and the 10th of last. So yes, we do. I'm sorry. Let's flip back to 91 real quick.
What numbers do we have?
Okay, so it says 91 to 93 was numbers 8 through 48 evens.
Page what?
91.
91 to 93. So, and I even had it written right here in front of my face, where if you've got this sheet, like what I did is I put the corresponding with which section we cover, I put down. So anyway, so starting with 91, 91 to 93 was 8 through 48 evens. So let's flip back to that. All right. Starting with number 8, we were doing our if-then statements in this section, talking about, remember, if P, then Q. We talked about how that is our conditional statement. We learned that the P represents the hypothesis, and what does Q represent?
Statement.
The conclusion. Okay, so in this situation, we've got our hypothesis and a conclusion. And so P then Q, and then this is where we have, that's our conditional statement. And then if we flip-flop it, it's called the converse. If we negate both sides or have the negatives of both sides, that's called the inverse. And then our contrapositive is when we have the negatives and it's flip-flopped. Okay, so it's basically the combination of converse and inverse makes up contrapositive. Okay, so number 8. Our directions say, using P and Q below, write the symbolic statement in words. So remember, if P then Q is our original conditional statement. So what does Q then P represent? Which is that I just went over? Inverse, converse, contrapositive. What does that one represent?
Converse.
The converse. It's flip-flopped. Good. Let's look at number 10. Not P. Now look at that one. That one's a little tricky because it's not P, then not Q. So it's not any of those, it's not converse, inverse, or anything. It's going to be, did they call it the negative or negation? I think they called it the negation, and that is on page 88. Look at the very top of your textbook on page 88. Okay, at the very top you can see is the second sentence says that the symbol for negation is the little wavy line, and that is written before the letter. So the way we would describe number 10 is the negation of P. Okay, so number 10 is the negation of P. Let's look at number 12. Okay, 12 has the arrows going back and forth. Do you remember what that one was called? It is a biconditional statement, and that was our if and only if. If and only if statement. Okay, remember that means that it's true P then Q and Q then P is true as well. So that's our biconditional statement. Okay. All right, then we moved on to number 14, and we talked about it says, given the statement is in the form P then Q, write P and Q. So the first thing you had to do was to identify P and Q. Then you had to write the inverse and the contrapositive of P then Q, both symbolically and in words. So let's look at number 14. It says, if Jed gets a C on the exam, then he will get an A for the quarter. All right. So the first thing I have to do, we said that is P then Q. To write the inverse, it would be if Jed gets an A for the quarter, then he gets a C on the exam. Okay, and we would write that as Q then P. Then the contrapositive would be if he does not get an A for the quarter, then he does not get a C on the exam. So you'd have the negation of Q, then the negation of P. Okay. 16, if the fuse has blown, then the light will not go out.
Wait, what's the evens?
Huh? Yeah, so it's number 16 is even. So if the fuse has blown, then the light will not go out. So that's our conditional statement. So P is if the fuse has blown. Q is then the light will not go out. So to do the inverse, to flip-flop it, if the light will not go out, then the fuse has blown. To do contrapositive, I have to negate it when it's backwards. And so it will be if the light will go on, then the fuse has not blown. Okay, so that would be the negation of Q, then the negation of P. Because it had not in my conditional statement, when I take the negation, that not goes away. Okay. Number 18, if you dial 911, then there is an emergency. So P is if you dial 911. Q is then there is an emergency. So if P, then Q. Inverse, if there is an emergency, then you dial 911. That's going to be Q, then P. That is inverse. Contrapositive is if there is not an emergency, then you will not dial 911. So not P, then not Q. And finally, 20, if it is not raining, then Petra will ride her bike to school, P then Q. Inverse, if Petra rides her bike to school, then it is not raining. So that is Q then P. And then the contrapositive is going to be if Petra will not ride her bike to school, or if Petra does not ride her bike to school, then it is raining. So that's going to be not Q, then not P. All right. 22. Decide whether inductive or deductive reasoning is used to reach the conclusion. Remember, we talked about inductive and deductive reasoning. Inductive reasoning is making a conclusion or making a guess based on a pattern, based on examples of something happening, whereas deductive reasoning is based on facts and truth and things that have been proven. Okay? So if we look at number 22, it says, if you live in Nevada and are between the ages of 16 and 18, then you must take driver's education to get your license. Marcus lives in Nevada, is 16 years old, and has his driver's license. Therefore, Marcus took driver's education. So what do you think about that one? Is that inductive or deductive?
Deduction,
Why?
because everybody was again in drivers from between ages 16 and 18. So
Okay, because it's a law, it's factual information. Okay, so we know that in Nevada, if you have a license and you're 16 years old, then you had to have taken driver's ed. Okay. Number 24. We're using this state whether the argument is valid and explain your reasoning. So we've got our two pictures of angles A, B, and C. We can see that A measures 30 degrees, 60 degrees. So if two adjacent angles form a right angle, then the two are complementary. Because angle A and angle C are complementary, then angle A and angle C are adjacent. Okay, so let's think through this for a minute. In looking at these angles, what can we tell is true for angle A and angle C?
they're going to equal a right angle. It's 30.
Okay, so they are complementary, but are they adjacent? Why? Because they're not right next to each other. Remember, adjacent angles share a common side. They're side by side. And so these are not adjacent. They are complementary, but they are not adjacent. All right, so it is not a valid argument. Number 26. State whether any conclusions can be made using the true statement given that x equals 3. So if I plug in 3 for number 26, I would have if 3 is greater than 2 times 3 minus 10, then x equals y. So let's look at this. So if we plug in 3, then we can see that 3 is greater than 6 minus 10. 6 minus 10 would give us a -4. 3 is greater than -4. And so then x equals y. So then we can conclude that that would be true if it's telling us that x does equal y, because our inequality makes a true statement, then that would be a true statement. Okay? It can be concluded that x equals y. 28, if 4x is greater than or equal to 12, then y equals 6x. So if we look at that one, plug in 3. 4 times 3 is 12. 12 is equal to 12. So because we have greater than or equal to, that makes a true statement. And so y equals 6x. When we look at that, again, we can see that that is a true statement because we find that when we multiply by 2, that equals 12. Okay? Looking at number 30, law of syllogism, to write a statement that follows the pair of true statements. 30, if the sun is shining, then it is a beautiful day. If it's a beautiful day, then we will have a picnic. So what are the two things that we can relate here based on the law of syllogism? If the sun is shining, we're going to have a picnic. All right, 32. If Ginger goes to the movies, then Marta will go to the movies. If Yummy goes to the movies, then Ginger will go to the movies. What can we conclude here?
Yummy goes to the movies, and
Okay, well, so we have to leave Ginger out of it because of syllogism, but so it would just be if Yummy goes to the movies, then Marta will go to the movies. All right, 34. The Kolob arch, I guess that's the way you say it, I don't have a clue, is the world's widest natural arch. The world's widest arch is in Zion National Park. So the Kolob arch is maybe or is not in Zion. What can you conclude there? It gave us the options to choose is, maybe, and is not. It is. Good. It is in Zion. Moving on to 36 on page 93. We have two sets of parallel lines that intersect. Big Ten Conference changes course. Uh-oh. Getting my ESPN alerts. Football. All right. So if we look at the diagram, we see two pairs of parallel lines that intersect with one another. So it says in exercises 36 through 42, use the diagram to give a reason for each true statement. In the diagram, the measure of angle 2 is 115 degrees. The measure of angle 1 is congruent to angle 4, and angle 3 is congruent to angle 5. So for 36, it says that the measure of angle 2 is 115 degrees. So basically what we're doing is we're using the laws of logic here. And so we need to give a reason for this. Okay? So where did this information come from? It's the given. They gave it to us in the beginning, in the statement at the top. They told us that the measure of angle 2 was equal to 15 degrees. So that's the given. Again, we're trying to get used to taking this information in. All right, let's look at number 38. Okay, we're going from P2 to P3. It says if the measure of angle 1 equals 65 degrees, then the measure of angle 4 is equal to 65 degrees. Okay, so what information, how do I know that angle 1 and angle 4 are going to both equal 65 degrees? Because they're congruent, yeah. So we know that they are congruent. 1 and 4 in the directions tell us that they're congruent, so we know they're going to be equal. Looking at number 40, the measure of angle 3 is 65 degrees, and the measure of angle 5 is 65 degrees. How do we know that? Congruent again. 42. It says P1 to P3. If the measure of angle 2 is 115 degrees, then the measure of angle 6 is 115 degrees.
They're also-
Hmm?
they're also or linear.
So hold on a second. So we know that and I guess what gets confusing here is not going step by step through each of them, but because you have to look at previous examples. So basically on this one, 2, okay, so see if you can follow this as I explain it, okay? We know that angle 1 and angle 4 are congruent, right? So we can see that 1 and 4 are congruent. So that means that we would know that we'll point to it up here. Okay. So if we know that these two are congruent here, right? Then that means these two are congruent here, right? These two are going to be congruent, and these two are going to be congruent. Okay? So we can see, based on congruence, we can see that. And so if we have 2, which is right here, okay, then here we would have 1 and 2. Like if I was going to renumber them, then let's see, what do we have? 1, 2, 3, 4, 5, 6. How about this? Let's just make up our numbers. Let's make this 7 and 8, and this guy will be 9. Okay? So because these are congruent, we know that these will also be congruent. 7 and 9 would be congruent. Oh, we didn't line up 1 and 10. So 2 and 10 are congruent, so we know 8 and 6 will be congruent. Okay? So by looking at those, by looking at the other ones that are congruent, then we can see that 2 and 6 are going to be congruent, because basically 1 and 2, 1 would be congruent to 4, so 7 would be congruent to 9. So if 2 would be congruent to 10, and 8 and 6. Does that make sense? Does that help? Can you see how these things will be congruent to one another? So therefore, it would make 2 and 6 be the same measures. And really the only other way that I could do that is if you actually sat and filled in, when in doubt, always go this route. Hey, that rhymes. So we said that angle 1 is 65 degrees. We know that angle 2 is 115 degrees. So angle 7 is 65 degrees. Angle 8 is 115 degrees. So that means angle 6 is 115 degrees. 65, 65, 115, 115, 65, 115, 65. So I can actually go ahead and fill in the measures for each of these. Okay, and so then I can see that we're trying to do 2 and 6 are both 115 degrees. So if you know this is 180, and I know one measure, and then I can go ahead and label all of the congruent ones with that same measure, and then I can label all the ones that are congruent to 2 with the same measure, so therefore I can see that 2 and 6 are congruent. Okay, maybe that's better just by writing the numbers in and seeing it. Okay, so that covered through 42. Was that all we had in this section?
46.
46 and 48. Okay. In exercises 45 through 48, use the true statements to determine whether the conclusion is true or false and explain your reasoning. If Diego goes shopping, then he will buy a pretzel. If the mall is open, then Angela and Diego go shopping. If Angela goes shopping, then she's going to buy pizza. The mall is open. So can we conclude that Angela and Diego went shopping?
Yes.
Yes, that is true. And 48, Diego had some of Angela's pizza. False. We don't know. He might not have. We don't know. Our information didn't tell us that. All righty, so we finished up that. Then, page 99 to 101, 10 through 32 evens. So starting with number 10, symmetric property of equality. If measure of angle A equals the measure of angle B, then
Wait, where are we?
page 99. The measure of angle B equals the measure of angle A. Good. Remember, symmetric means mirror image, so it's going to be reversed. Number 12, substitution property of equality. If LK plus JM equals 12 and LK equals 2, then what?
JM equals 6. Oh, no, 10.
JM equals 10. Good. 14, division property of equality. If 3 times the measure of angle A equals 90 degrees, then the measure of angle A equals 30 degrees. Good. Very good. Okay. 16 on the next page. In exercises 16 through 23, solve the equation and state the reason for each step. So number 16, P minus 1 equals 6. I would need to add 1 to each side, so that's the addition property of equality, so P equals 7. Number 18, 2R minus 7 equals 9. I would need to add 7 to each side first, addition property of equality. So I'd have 2R equals 16. Using the division property, I would divide both sides by 2, so R is equal to 8. Number 20, 3 times 2t plus 9 equals 30. I need to distribute first. So I'd have 6t plus 27 is equal to 30. Then I'm going to need to subtract 27 from each side. And so that is going to be subtraction property of equality. So now I have 6t is equal to 3. I need to divide both sides by 6. So I end up with t is equal to 3 divided by 6, which would reduce to 1/2. So you could either have 3/6 or 1/2. And then finally 22, 26u plus 4 times 12u minus 5 equals 128. First thing I'd have to do is distribute the 4 to 12u minus 5. So I'd have 26u plus 48u minus 5 equals 128. I'm sorry, minus 20 equals 128. Then I would need to combine like terms. So I'd add 26u and 48u, and 26 and 48, 74. So I have 74u plus, I'm sorry, minus 20. 74u minus 20 equals 128. I'm going to, did I do that right? 26 and 48? Yeah.
20. Oh, yeah.
So, let me write, this one's got a lot involved. So I said what I've got, 78u minus 20 equals 128. So I'm going to add 20 to both sides. So I have 78u is equal to 148. Divide by 78, divide by 78, and that's going to equal what? Am I even on the right page? No. Yes, Joanne here. Activities is yes. don't know why I wrote 78, 74. Why did I do that? Y'all help me. So this was 74. When I added it, I did it right, but I carried it up there wrong. So U is equal to 2. All right. Number 24. Okay. So let's go ahead and take a look at this. Let's see what I wrote all over it. I'm gonna clear that out. Okay. So let's look at 24, logical reasoning. In the diagram, the measure of RPQ is equal to the measure of RPS. Okay, so the first thing I'm gonna do is look at RPQ is equal to RPS. So what do I know about that? If those two are equal to each other and they're in these, they contain this, it's the same angle, what do I know about? A couple of things I know about that. All right, we'll take a break and we'll come back and talk about that.
That was so.
Okay, I did not have time to watch the video and I really didn't know what we were supposed to, so I put down the numbers of like what we're supposed to do, and then I'm gonna go back and do it.
Very
Try to
good.
do it tonight.
Yeah, and then when you watch the video, it'll tell also what the homework was at the end. All right. It changes so fast. It's so bad. Oh my God.
I knew I should have brought like a jacket or a sweatshirt. Are you a singer?
Yeah.
I'm like,
I don't know why. I just wanted to take a bunch of math classes before I take my ACT in December. So my mom's making me take ACT class, algebra 2, geometry, and I'm like, I'm gonna die. It's fun. What classes are you taking?
This class, world history, biology, and some literature class with Dr. Taft, which I don't like at all.
Fun. What grade are you in?
I'm a junior.
I'll show you junior. It was fun. I was extremely clueless. I just got seen a picture of Meg yesterday.
This weather. What's the matter?
Yeah, the wind was trying to blow my hair off, so that was.
What kind of weather is this?
This weather is insane. My mom went up.
I don't literally just he's in Pensacola, but I mean, I don't even know if it's there.
Yeah, I think it starts in Pensacola. I heard something.
I'm not asking.
I have a friend in Pensacola. And my grandparents live down in Shipley.
It's really bad in Panama City, so.
Yeah.
Yeah, it's cold. Nice. It's not September. It should be shots at. I gave up. I gave up Thursday.
All right, so the copier's jamming. Each time it makes one copy, it jams in like 4 places. Then you take it apart, you know, push it out, and then you'll run one copy and it jams again. So I will email you guys copies of this. Sorry about that. Okay. Plus, hopefully the copies will be better that you print out because I'll be able to make it darker because it was coming out really funky. All righty, so let's go back to that 24 logical reasoning. When we saw that RPQ is equal to RPS, okay, we can tell that what would we call angle PR right here? A bisector, okay, so this is an angle bisector. It cuts angle SPQ in half, okay, so now I also can see that SPR plus RPQ would equal SPQ. So we know that that is, so as we're starting to look at these figures, start running all these things through your mind that you know, okay? So the measure of RPQ equals the measure of RPS. In that situation, that is our given, okay? So basically they were kind of doing a proof here. That's our given information, okay? And Then we look and the measure of angle SPQ is equal to the measure of angle RPQ plus the measure of angle RPS. So what we just said there, that SPQ is equal to RPQ plus RPS. Which postulate is that? Angle addition postulate. Good. Then we have the measure of SPQ is equal to measure of angle RPQ plus the measure of angle RPQ. So what did we do here from here to here? We substituted this for this, okay? And then finally, we said that the measure of angle SPQ equals 2 times the measure of RPQ. Notice that we took these two here and we did kind of the reverse distributive property, right? Okay, so that's going to be distributive property right there. So that's what it was doing, is going through those steps. Kind of basically what this was doing here was getting you ready to start doing proofs. Okay. Since we're kind of backtracking, it's kind of going a little backwards. Sorry about that. So on this, we have through 32 evens. That was 24. Any questions about that? I don't want to just gloss over something if you're still hung on it. Okay. 26, it says in exercises 26 and 27, give an argument for the statement, including a reason for each step. So in 26, it says, if angle 1 and angle 2 are right angles, then they are supplementary. Okay, so what would your argument be for that? What tells us that? Okay, they're both 90 degrees. And so 90-degree angles add together to make what? 180 degrees. So we know that they are, and that was, come from back. What was it, the law of supplements? Is that what they called it? But basically, supplementary angles, okay? 28. Some facts about the maximum banking angles at Daytona International Speedway are corners 1, 2, 3, 4 are at the right. Find the measure of angle 3. Explain your steps. So if it says banked corners are described on page 98. If we look at what they've told us on the right-hand side, that the measure of angle 1, angle 3, and angle 4 are 93 degrees, okay? 1, 3, and 4 are 93 degrees. 2 and 4 are 62 degrees. 2 and 3 are equal. 1 and 2 are equal, okay? So what I need to do here, if I know that 1, 3, and 4 are 90 degrees and 2 and 4 are 62 degrees, we need to find the measure of 3. Okay, so 2 and 3 are equal. 1 and 2 are equal.
That kind of confusing us. I think I get it now.
Okay, so when we look at this, hold on just a minute. Let's look back where it says CM 98. Okay, we had gone through that. I was trying to figure out when we had talked about. So when we talked about the banking, the bank turns, that was one of the example 5 from using Talladega. Okay, So basically what it tells us in that example is kind of a similar thing where we have the measure of 1 and 2 is 66 degrees, 1, 2, and 3 is 99 degrees. And so you're able to plug in pieces of information that they have given you. So like in this one, they gave us 1 and 2 was 66 degrees. So then that meant I could substitute those in. So here, so because 2 and 3 are equal, then I know that what can I substitute in at the very beginning for the measure of angle 3?
31.
And actually, what could I substitute here for 3 and 4? Since 2 is equal to 3, that means 2, this measure here will equal this measure here. So since these are the same, that means that 3 and 4 are going to equal 62 degrees, okay? So I'm going to start by subtracting 62 from 93 and end up with 31 degrees, right? So that means that the measure of angle 1 is 31 degrees. And the measure of 3 and 4 together is 62 degrees. So if 1 is 32 degrees, then what is angle 2?
31.
31 degrees.
The way I did, I just divided the 3 measures by 93.
But they're not all the same. Well, I guess, yeah, I guess they are.
Divided the 3 measures, 1, 3.
I gotcha. So you said you just divided 93 divided by the 3 that were added together. And so that worked out in this one since we know that they're all equal to each other. And so, so they're all going to be 31 degrees there. Okay. So any questions about that? So basically we can use substitution to figure it out. The only time that that would not work is if for some reason these angles were not all equal to each other. Okay. Finally, number 30. It said to use the result from exercise 29 to figure that. So I guess you ended up having to find using 29. But basically, number 30 would be 8%. Any questions on that? And then our last one was 32, multi-step problems. State a reason that makes the statement true. If 4 times x minus 5 plus 2 equals 0.5 times 12x minus 16, then 4x minus 20 plus 8 equals 4x minus 8. What makes that true? What do you have to do in the left-hand side? We see a number outside of parentheses. What is that? Distributive property. B, if 4x minus 20 plus 8 equals 6x minus 8, then 12x minus 20 equals 6x minus 8. What is our reasoning there? Okay, well, on that one, we're simplifying because what we're doing is we are combining 4x and 8x to make 12x. Okay, so that one is going to be simplifying. Look at letter C. If 12x minus 20 equals 6x minus 8, then 6x minus 8 equals negative 8. I'm sorry, 6x minus 20 equals negative 8. What step is that one?
Substitution.
Subtraction. Letter C is subtraction. Okay. D, if 6x minus 20 equals negative 8, then 6x equals 12. What is that one going to be? Addition. E, if 6x equals 12, then x equals 2. What is that one? Division. And then you could basically go through and list all of those steps out that we just went through to write the argument for letter F. Okay, so basically you've got your A would be your given, that's the beginning of it, and then your to prove is x equals 2. So we just kind of basically we've gone through that step by step through steps A through E. All right, so finally, I think we got that homework. And then let's go back to where we had already started checking. Make sure we've got all this wrapped up. Yeah. So we finished 32 and 34 on 107. So now section 2.6. Okay. 113, we had 12 through 18 evens. So we've got a figure. We have some given information that EHC is equal to DHB and AHB, which is equal to AHB, which is equal to 90 degrees. So I can go ahead and look and say, all right, I'm gonna go ahead and fill everything in that I know. That EHC, DHB, and AHB are all 90 degrees. So AHB, 90 degrees. DHB, which is going to be this one right here, is 90 degrees. So I'll go ahead and just put my boxes. So I know these are all each 90 degrees. Okay, I can put my boxes in to indicate that. So if the measure of angle 7 is 28 degrees, what do I know the measure of angle 3 is? Okay, 28 degrees. If the measure of number 14, if the measure of angle 3 was 34 degrees, so I'm going to take that away for a minute. If this was 34 degrees, then what would the measure of angle 7 be?
30.
Oh, I'm sorry, I jumped to the wrong one. The measure of angle 5. So think about this for a minute. The measure of 3 was 34 degrees. Then what is the measure of angle 4? If 3 is 34 degrees, what is measure of angle 4? 56 degrees, right? So, that means angle 1 is going to be 56 degrees, and angle 7 is 34 degrees. So then, what is angle 5 going to be? 34 degrees. Okay. Okay, look at 16. If the measure of angle 7 is 31 degrees, then what is the measure of angle 6? 59 degrees. Okay, if 7 is 31, then 6 is 59. Okay. Number 18, it says copy and complete the proof of the congruent complements theorem. Okay, so we've got our statements here looking at, we've got our given. So under our statement side, okay, let's look at our statements. We have angle 1 and angle 2 are complements, angle 3 and 4 are complements, angle 2 is congruent to angle 4. So reason 1, what is that? Our given. Look at number 2. Number 2, based on our reasons, is the definition of complementary angles. So what do I need to have there? Good. Angle 1 and angle 2 equals 90 degrees. We have in the given that they're complements, so now we need to go ahead and show, based on the definition of complementary angles, that angle 1 plus angle 2 equals 90 degrees. Angle 3 plus angle 4 also equals 90 degrees. So that's number 2. 3 tells us that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4, and they already told us that's the transitive property of equality. Now, step 4, or for statement 4, it has measure of angle 2 is equal to the measure of angle 4. This is going to be the definition of congruent angles. Good. Step 5, measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. Substitution, basically I've just taken, I've been able to substitute the information and expand it out. So once I've done that, in step 6, how did I get to the measure of angle 1 equals the measure of angle 3? Not the transitive. Notice what's missing from this side and this side. Subtraction property. We subtracted the measure of angle 2 from each side. We subtracted the measure of angle 2 from each side. And so that is our subtraction property. And then looking at 7, the definition of congruent angles, what is that going to be? The measure of angle 1 is congruent to the measure of angle 3. Remember, this right here is always going to be your last in the statements. So hopefully when you're filling in, you know that the first statement is going to be your given. The last statement is going to be what you're trying to prove. Okay. Page 114, we had 20 through 28 evens. Okay, on 20, make a sketch if you need to, given the information, then state all the pairs of congruent angles. So 20, I have XYZ and VYW are vertical angles, and XYZ and ZYW are supplementary. VYW and XYV are supplementary. Okay, so let's go ahead and take a look at this one. What can I tell is congruent to each other? What is congruent to XYZ? VYW, good. And what is congruent to XYV? That's going to be ZYW is also congruent to, or is congruent to XYV. 22, angle ABC and angle CBD are adjacent complementary angles. Angle CBD and DBF are adjacent complementary angles. So what do I know is congruent to ABC? DBF. What is congruent to ABD? CBF. Good. Okay, so on 24, I think I gave you the statements. So I gave you the statements on 24. So our first statement is the given. Our second statement was the definition of complementary angles. Our next step was, no, it's going to be transitive. Measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. So that's going to be transitive. Then measure of angle 1 equals measure of angle 3. It's going to be subtraction property because we took away the measure of angle 2 from both sides. And then finally, our last step, measure of angle, our angle 1 is congruent to angle 3. That's our definition of congruent angles. And then 26, I gave you the reasons, and you had to fill it out. So look at 26, okay? Step 1 was the given. What is that? Angle 5 is congruent to angle 6, okay? Okay, and we can also see it says first show that angle 4 and 5 are congruent, 6 and 7 are congruent, then use the transitive to show that 4 is congruent to 7. So you can see the picture that went along with this. So we have the given. So then step 2, we have that it's the definition of a linear pair. Okay, so what does that tell us? So if we had linear pair, why did I put linear pair on that? No, it doesn't, because it doesn't even have linear pairs listed on it. I'm not sure why I told you that. It should be vertical angles theorem. Yeah, so step 2 should be vertical angles theorem, because that's what it's showing us, is that we've got 4 and 5 and 6 and 7. I don't know why I told you guys that, but angles 4 and 5 and 6 and 7 are vertical angles, so that should be the vertical angles theorem. So then I had, I wonder if I just wrote things down from the wrong problem. That's what I did, is I wrote down things for number 25 instead of 27. I'm 26, I'm sorry. I gave y'all information for 25 instead of 26. So vertical angles theorem. So then the next step would be that angle 5 is congruent to 6, and that's from the given. And then finally the transitive tells us that 4 is congruent to 7. So sorry about that. I totally messed that one up on y'all. Somehow I'm not surprised. All right, 28. So you can see that we have got 3y is one angle, 10z plus 45, 4y minus 35, 3 times 6z plus 7. Okay. So what do we have to look at here to know how to solve? I can see that these two are vertical angles, right? So what can I do to solve for y? 3y equals 4y minus 35. So what does y end up equaling there? Y equals 35 when you solve that. Okay, and then we can also see that these two are equal to each other. So you would set up 3 times 6z plus 7 equals 10z plus 45. So what do you end up finding that z is equal to? First, I want to make sure I'm on the right problem. Okay, so let's work through this one. So this is 3 times 6z is going to be what? That's an 18z, right? So I have 18z plus 21 is equal to 10z plus 45. I'm going to move my 10z. So now I'm going to have, let's see, that's going to cancel. So I have 8z plus 21 equals 45. I need to subtract 21 from each side. So 8z is equal to 24. Divide by 8, divide by 8. What does z equal? 3. All right. So we finally get through it all. Praise the Lord. Okay. So now you can see that this was the end of the chapter. Chapter summary. Okay. So let's go ahead and look through. Section 2.1 was dealing with our conditional statements, if then, hypothesis and conclusion. Okay. 2.2 definitions and biconditional statements. We went on to talk about our inverse, converse, contrapositive. We talked about our biconditional statements, that if and only if. Okay. 2.3 dealing with deductive reasoning. This is where we incorporated our symbols. We talked about how deductive reasoning is based on examples, is based on fact, is based on things that can be proven. 2.4 reasoning with properties from algebra. Basically, this was the part where we said, oh yeah, remember when we solved equations, the reason of equations the way we did was because the properties of equality. So if I subtracted from one side, I had to subtract from the other. If I divided one side, I had to divide the other. So all of those properties. 2.5 proving statements about segments, and 2.6 is proving statements about angles. Okay. So what I want you to do for your homework is I want you to go through the chapter review. Okay. So let's see. This is going to be pages 118 through 120, and there's only 21. And actually, I'll tell you what, you don't have to do 20 and 21. So it's actually 1 through 19 on pages 18 and 19. I do want you to read over the proofs on 2.5 and on page 120. So let's see, we're doing the chapter review. It'll be numbers 1 through 19. And then I want you to read through these proofs.
Where?
2, 5, and 2, 6, which are on page 120. Page 120. I'm sorry, not 120. I'm looking at the wrong page. Yeah, 120. Page 120.
Yes, ma'am.
2 proof about angles,
Oh.
and 2, 6 is a proof about angles. I want you to read through those and look at them. Okay? You do not have to do numbers 20 and 21. You're only going to do numbers 1 through 19 to review. I do want you, though, to flip through the chapter.
Is this due next Wednesday?
This will be due next Wednesday. So what's going to happen, though, is that
We need to do all of them from 119.
so what I'm going to do is tomorrow you will get your test, but it won't be due until next Wednesday. I will go ahead and give it to you tomorrow. So between tomorrow or between today and next Wednesday, you will have done the chapter review, and then you will do your test. I will send you the answers for the chapter review, because the last thing I want you to do is have the wrong answers and take a test and you have the wrong answers to study about. Does that make sense? So, so this afternoon, I will send you the answers. Don't just look at the answers to do your homework. Like, do it and then check your work. Okay. So chapter review, and then I will send you guys the email of this, and hopefully, actually, yeah. I mean, what I'll do is I'll try to make copies of it tomorrow. So don't print it out yet if you don't want to. Don't print your folder information just yet. Hopefully they'll have the copier because they're supposed to call. Hopefully they'll get here today. I don't know. So if I can make copies of it for you tomorrow, I will, and then whatever. Okay. Wednesdays are rough because we've got so much homework to go through, but I just really don't know what other way to do it, because I hate to say, hey, you've got to get all this homework done tonight when you've got other stuff to do for tomorrow too.
Yeah, that
We're
didn't
gonna
happen
like
last year.
So we're just going to go with it. All right. So chapter review, and
Read over each one.
read through the proofs on 2, 5, and 2 on 120, 2, 5, and 2, 6.
And our test is due next week.
Test will be due next Wednesday. I will hand it out tomorrow. All right. Any questions before we get ready and go? Is there anything in particular that you feel like you're struggling with all of these? When we look at, you know, our conditional statements, I feel like everybody's pretty comfortable with those.
Page 91, 8 through 4, I'm kind of stumped on those.
Okay, let's flip back to those. Page 91. Which ones?
8 through, I think it was 8 and 9.
8 and 9. Okay, so number 8. So basically it's saying that and Q than P, so we were doing the inverse. So if you look at what they gave us, P and Q, that points, if for P is X, Y, and Z are collinear, points X, Y, and Z lie on the same line. So if you put it in a P then Q statement, that would be if points X, Y, and Z are collinear, then points X, Y, and Z lie on the same line.
Yeah.
So that was if points X, Y, and Z lie on the same line, then points X, Y, and Z are collinear. And then for number 10, the not P, you would just write that as points X, Y, and Z are not collinear, because that was the negation of just P.
Okay. So P is your hypotenuse. and
Yes,
Q
is your conclusion.
conclusion.
Uh-huh,
Okay.
yes. Okay.
I think that makes sense.
If you get a chance,
Number 11 also kind of freaked me out.
yeah, the not P, the not Q.
Yeah, when they
So-
start adding all the nuts, I'm like, what?
Yes. So if you get a chance tonight to kind of read through, look and see if there's anything that you do want to review before I give out the test for y'all to have next week. If there's anything that you have questions about, please do let me know. Okay? Yes.
We figured out 18, like I didn't see the bottom part, so I was like, this is so good, and then I figured it
And
out.
you saw. Awesome.
So my
Very
mom's
good.
wondering if you could text her if we figure it out during class.
Okay.
So,
Sure. Okay. Perfect. So it was 18 on which page, Easton?
The last assignment, like the third assignment.
Okay, it was this proof. Was it that one or
No, it was later.
later?
Right. It was where you gave us.
This one?
Yes, ma'am.
Okay.
I didn't see that bottom part, so I was like,
Oh, that you had to use this
Yeah.
right here.
Yeah.
Yes, that it was all of this.
Mhm.
Okay, perfect. Very good. Yes. Go ahead and flip on the lights and you can open the door and we actually have, we've got like 7 minutes before the bell rings, so we can't go out in the hall yet. All right, Keely, any questions?
I think I'm good for now. I'll definitely let you know if I think of some though. So thank you.
Thank you. I know, yeah, if there's anything that I know you had to do some catch up and stuff like that. So if there's anything that you need help with, be sure to let me know and we can do a one-on-one Zoom if we need to go through anything. We will get it done.
Yes, ma'am. Thank you so much. That'd be great.
All righty, sounds good. We'll talk to you soon. We'll see you tomorrow.
Yes, ma'am. See you tomorrow. Have a good day.
Daddy gets better.
I'm sorry, what did you say?
I said, I hope your daddy gets better.
Oh, thank you. Yes, ma'am.
Sick, so stay away from him.
Yes, ma'am. We've been trying to stay separated. It's been kind of rough, but we've been trying to keep everyone away. So,
Well, all righty, we'll see you tomorrow.
yes, ma'am. Bye. Thank you.
Bye. Thank you.
I don't understand that. It like literally, we get through our stuff online in 50 minutes.